Hello, everyone. We are here to talk about data governance in the hybrid cloud and how Privacera and Databricks can help you achieve that. The title of this talk here is to um, find and protect your crown jewels in Databricks with Privacera and Apache Ranger. My name is Srikant Venkat. I am VP of Product Management at Privacera. I used to manage the security and governance portfolio at Cloudera, including shared data experience, in Apache Ranger, Apache Atlas, etc. And we are here to talk about how Privacera can help you move your workloads responsibly to the cloud and work on top of Databricks as a solution and give you the Apache Ranger functionality for security and governance and data governance, other data governance capabilities in the cloud. Who are we? So Privacera was founded by Balaji Ganesan and Bosco Durai in 2016. They were the original creators of Apache Ranger, and Hortonworks purchased Secure, which is the company that they founded, and the code was open sourced as Apache Ranger. And since 2014, a lot of big data deployments have Apache Ranger as their core authorization and audit engine, and the community has added a lot of functionality there. In 2016, Balaji and Bosco founded Privacera to take Apache Ranger solution to the cloud and build capabilities to address solutions such as Databricks and other AWS, Microsoft, Google, etc. in the cloud with the same set of capabilities. Our platform became generally available in 2017, and today we have a number of Fortune 100 customers using our solution at scale. And we have vetted and experienced and accomplished set of innovators in the team, both in the community and outside. And our mission is to solve the data democratization problem that most enterprises face. Most enterprises today, as they're moving to the cloud, have the dual mandates of maintaining the data governance while democratizing this data responsibly. As you can see in this chart here, the data volumes are exploding, but the amount of usable data that can be responsibly shared and that meets the compliance guidelines that are coming up either as external regulations or as internal mandates is shrinking. So the amount of, there's a huge gap between the amount of data that is available and the amount of data that can be shared and used for such insights. Our goal at Privacera here is to close that gap. As you can see here, we've shrunk that. Our primary use cases are as follows. We help our customers, enterprise customers who are either familiar or new to Ranger, and we give our customers the ability to move all of their the robust security and governance features that are available via Apache Ranger, help them migrate safely to the cloud in a compliant fashion while being in compliance in terms of workflows and automation to support the emerging regulations such as CCPA and GDPR. And in doing so, being able to democratize this data so that it can be shared securely and widely across their organizations to support better insights and decision making. We cover traditional big data and relational and other platforms on-prem as well as the public cloud on Azure, AWS, and Google Cloud. And in particular, we are first-class partners with Databricks, and we have a lot of deep integration on the Spark side, and we work with the community and Databricks in this regard to make sure that our solution can help our customers smoothly migrate from on-prem to the public cloud deployments and also support hybrid cloud deployments while running with Databricks efficiently. What does the Privacera solution offer? Without the Privacera solution, if you look at all of the different cloud services, they have their own authorization model, they have their own auditing frameworks, and they have their own data governance frameworks that might be involved. And if you look at it, this is as widespread as the cloud, and even within a particular public cloud providers' services, there is a lot of heterogeneity and a lot of duplication of the data and the policies that need to happen to make sure that you get the consistent governance. So as a result, enterprises are struggling with how do you impose this layer of compliance on top while being able to share the data and responsibly across the enterprise and get the analytic value out of the data investment by moving to the cloud. So as they migrate to the cloud, they have this challenge with a lot of this heterogeneity and stovepiping of all of these different services, which makes it very difficult for them to manage governance and security, and in particular authorization and auditing, as well as data discovery centrally. So with Privacera, we aim to centralize this. We provide a single pane of glass that can be used to discover where your sensitive data is and classify it, and use that and other capabilities on the platform to provide centralized access control at a very, very fine-grained level, and also provide automated compliance workflows that will help democratize this data while keeping it in compliance with external regulations. A little bit about our data discovery architecture. We can connect and scan to scan variety of cloud databases, cloud object stores, database and cloud warehouses, etc., as well as on-prem databases, warehouses, file systems, object stores. We very heavily leverage Apache Spark, and we leverage Databricks very heavily in our scanning technology. The scanner agents can go and in process query the data, and then they use a variety of algorithms that we'll show you during the demo, such as everything starting from regular expressions to dictionaries to machine learning models to go and scan this data, pattern match, and use a variety of rules, and then apply different classifications and other metadata, which is stored in our metastore, which is a cloud native metastore that is scalable and relies on the cloud infrastructure natively. And all of that is available through our security envelope with the Apache Ranger functionality. And you can use these discovery-driven classifications or labels to drive the security decisions and authorization decisions, as well as understand the audit and analytics and the usage of the data across your enterprise. Another key component of our platform is the access control architecture that is predicated on the Apache Ranger framework. In the traditional big data world, the Apache Ranger framework works through a plugin model where in services such as Hive or HDFS on-premise, there are plugins which run within the service in the same process that they receive all of these incoming requests for access. They consult a set of policies that are cached within this plugin or agent, and these get pulled down from a central portal where the users can go and author the policies, and they're maintained in a centralized database, and distributed agents such as these plugins are provided to enforce the policies or have these local enforcement points that inspect the incoming request, match it up against the policies, and make a very quick policy decision whether this user or group or role under that context of data usage can actually access this data. And once the decision is made, the engine, which may be Hive or Spark or other engines, can natively do their enforcement and optimization. So we only do the check while in process and are not in the metadata. We are only in the metadata path and not in the data path. Similarly, we have extended this plugin model to cover cloud and object stores in Privacera, and we have other agents that run as a lightweight reverse proxy that inspects the traffic and inspects the content coming in and the metadata coming in to be able to make that authorization decision. We've also extended for cloud databases another model from Apache Ranger within Privacera, which does a policy synchronization. And this provides the capability to take the policies in a common form that's expressed in the Apache Ranger format, and then translate them down to typical grants or revokes that are available in the databases. So our plugin architecture for Databricks, we run within the Spark driver, and as and when the logical plan is created, we inspect the incoming request, make a quick policy decision consulting the policies that are pulled down from the centralized Apache Ranger service, and locally enforce that within Spark. So because of this, we are very highly performant, and we're able to provide authorization at multiple levels. In a Databricks context, this plugin is loaded via init scripts and is available for the life of the cluster. So essentially, the authorization checks and audits are inescapable, and we configure the system so that for the life cycle of the cluster within Databricks, our authorization engine is available. How do we extend the model in Databricks? So we work very closely with Databricks, and for the SQL, Spark SQL, R, and Python notebooks, we provide, in addition to the table and column level access control, we provide column masking, row filtering, classification-based policies, and dynamic policies, as well as centralized auditing. And in the case of the credential pass-through mode for your Java and Scala notebooks, etc., we provide both bucket object level access or file level access in ADLS, for example. And we have additional enhancements around being able to map these identities in Databricks in various formats, checking the policies for the underlying cloud object stores, and provide a lot of flexibility in terms of authentication schemes. Now let's dive into a quick demo to look at Privacera in action.
One of the first challenges that enterprises face as they move their data more and more into the cloud is to first determine what data lies where and how much of that is sensitive. The first part of Privacera platform is a discovery service that helps you precisely understand and locate where sensitive data is across your cloud footprint and your hybrid on-prem private cloud as well as public cloud resources. So what you see here is a typical enterprise footprint where we have multiple clouds as well as on-prem services. We have services from AWS, Google, Azure, Databricks, etc. And the discovery service helps you scan all of this information automatically and classify the data that is present in there. So for example, your data could be sitting in files in the cloud, or in columns in tables and databases sitting in the cloud, or data warehouses. We scan that entire footprint using the discovery service, and we can very precisely map and understand where various types of sensitive data, such as person names, social security numbers, zip codes, phone numbers, credit card numbers, etc., are located very precisely. And you can do this entire map and landscape across all of these heterogeneous services and get a holistic, comprehensive view of the sensitive data or toxic data, as the case may be, across this entire footprint. Furthermore, you can divide this entire landscape into what are called data zones. Think of the data zones as a way to segment your data and logically from multiple services. So for example, you could designate certain sets of tables and folders from, let's say, S3 and Redshift and Databricks Delta Lake files together as a particular zone. And in this case, we have defined several zones, data zones, which represent these logical divisions of the data for which we can apply various types of access and governance policies. So what's the benefit of providing these data zones? You can carve out different assets, and then you can look at the composition of these assets into a data zone and look at all the sensitivity attributes of those data zones. You can also have various workflows for compliance across these data zones. As an example, you can be alerted when you can have policies that will alert you whenever sensitive data is moved into a zone or across zones or between zones. You can de-identify data as it moves between the zones, and you can also alert, for example, when data leaves a particular zone as exfiltration happens out of that zone. So Privacera platform gives you a variety of compliance workflows based on the sensitivity that has been detected and various operations that are happening on those data zones to alert you suitably. So both of these capabilities will give you, as an example, all of the possible attempted data movements, and you can go drill down into each of these to see where did the data come from as a particular time. You can filter this over different scenarios. To understand how this data map is constructed and the different functionality available within data zones and alerts and monitoring that we reviewed, as well as lineage, let us see how the precise detection is accomplished through the discovery module. The first process in this is to register the data services as well as data assets sitting in cloud storage or in various databases in the cloud or warehouses in the cloud with the discovery service. So these scanners, which are high-performing Spark jobs running in Databricks or in Apache Spark, can scan the data and then produce the classifications or labels that are needed for sensitivity across this entire footprint. So the first process here is to register these data assets for the discovery service to be able to scan. Once you've registered these different data services or databases or platforms, then we can go set the scope of how we want to scan and what we want to scan. The first part is to define the scope of the scan. So we can include various resources. As an example, if you look at the Databricks part here, so we have two different tables from this customer database that we want to include in our scan. We can also similarly exclude various resources, be it tables, files, or databases, and define the scope of the scans. Then out of the box, we have various types of sensitive data that can be labeled or detected. And this can be extended with additional tags that can be customized according to the customer requirements needs. How do we detect and classify this data? So we use a variety of techniques in the scanning technology. So starting with very simple regex-based patterns, these can be applied both to the data content as well as the data context, such as the column names or file names. And you can apply dictionaries or inclusion-exclusion lists to match against column names or against column content. These could be useful for content such as person names, where you would be able to look at a common list and look at fuzzy matches or exact matches against those. In addition, you can have your own custom algorithms. As an example, in the credit card scenario, you may want to perform a Luntz check on the data once you've passed the content filters, as well as the content matches, as well as the dictionary matches for, let's say, a column name patterns. All of these different techniques can be composed into rules, and these can get very sophisticated in terms of inclusion, exclusion, as well as content and context classifications, and can be used to auto score or automatically classify the data, or to impose a review score. The way the classification output is provided is as a score between 0 and 100, with higher values indicating better confidence. Users can set a tunable score here. In this case, it's set up as 70 as a threshold, where any piece of data that has a score that lands above a 70 out of 100 is automatically classified. Anything between a 40 and a 70, a data steward or a human can actually review and make any adjustments as necessary for false positives, for example. Once you have chosen the scope of the scan and the techniques and the threshold, then you trigger a scan, and these scans will can be either triggered automatically based on what we call as file watches or other watching technology that we've got that looks for changes or updates happening in each of these scopes of the scans and automatically triggers the scan job. In addition, you can also do a manual trigger or set up a scheduled scan such as you would with a cron job. So there is a capability to set up the scans to run periodically, as well as the ability to auto scan based on changes happening in these data environments. The output of the scanner is a classification that's attached to a particular table or additional metadata annotation that are attached to a file or a folder, whatever the content is that is being scanned in the service. As an example, in Databricks, we've gone and scanned this table, and as you can see, the output of the scanner is a set of labels where sensitive data has been detected. We also indicate a sample of the data and what was the detection method that actually resulted in the score. And the output of the classification can be either a system classification, which is automatically approved since the score is above the threshold for system or automatic classification, or you could also see this data that can be that does not pass the threshold, the score where it does not pass the threshold. In this case is between 40 and 70, as we saw in the threshold setup. And as data steward or another person within the enterprise who has the role to curate this data can go and accept or reject these classifications. And then once they accept or reject, they can also give a reason, so we can use this information to improve the classifier over time. key part of the Privacera platform is the extension of the access management capabilities that were provided by Apache Ranger in the Hadoop ecosystem for a variety of services such as Hive or HDFS to the cloud object stores, databases, and warehouses, and engines such as Databricks and Spark running in the cloud. We will look at how Privacera has extended the Databricks security model to provide richer capabilities for access control, auditing, and key management services related to encryption. The unit of policies within Ranger, for those of you who are familiar with the Hadoop ecosystem, is a policy. And these policies can be role-based or attribute-based. And they're expressed very simply in the Ranger-like UI that we provide within the Privacera environment. A policy simply expresses who has access to what data, under what conditions, and what types of permissions do they have on those objects, underlying objects. In the case of Databricks, we can write policies at a database table column level, which is very, very fine-grained, and also write policies that pertain to a particular role, which is a composition of users and groups, as well as the groups themselves or users themselves. The users and groups can be sourced from enterprise systems such as LDAP and AD, and roles can be composed based on the user and group aggregations and can be nested within each other. So for example, rows can be nested within one another and groups can be nested within one another from your AD or Azure AD or other directory sources. The permissions can also be both positive and negative permissions and can be scoped down to what is the absolute minimum that's required. The Ranger policy constructs of being able to allow both positive and negative permissioning are also available by extension to Databricks and to the Spark environments. Let us now look at an example of a user accessing this data through SQL to Spark SQL from Databricks and see the different capabilities that Ranger extension from Privacera provides for Databricks environments. The first case here is that there is a very simple access to that sales data table in the sales database. Emily, who's a user here who belongs to that sales role, is trying to access this table by issuing a select star, which is showing me all the columns here. In case there is no policy that prohibits any access to for her to any of the columns, she will be able to see all of the data. But in this case, what if you wanted to protect the column called sales demand, which pertains to the sales for other reps, and she's not only able to see reps from a region, but also from UK, and we want to be able to restrict that. So if you have a policy that prohibits her access, you will see that she will get denied here. And when she's denied, we also generate an audit event, which collects a lot of the rich event metadata, such as who tried to access this, in this case, Emily, and what policy actually allowed or denied access for her, and what exact rules, what other policies were in effect when she was denied. So in this case, she had no policy that granted her access to this data set, so she was denied access to this table. Okay. The next level of fine-grained controls is around the column level. So you can not only write policies at the whole table, but you can also write for selectively for certain columns. In this case, Emily is only permitted these items, these columns, ID, country, region, city, and sales amount, and she's not permitted to see the name of the rep. So so in this case, when she runs this query, a different policy kicks in that provides this scope down access. And you'll see that being returned here. Another thing we notice here is that what if you want to restrict Emily to only see the data for her region without the names of the reps? So we can apply a row filter, which gives you row level security and will also give Emily only restricted access to those rows. Applying these row filters is dynamic, which means you don't have to maintain multiple views and permissioning around those views. And it makes it very, very simple to provide this type of access control policy to restrict the data and to show the right slice of the data by dynamically filtering and inserting predicates into these policies. So you will see that in this case, a row filter policy has been applied. And if you look at what the row filter policy construct here is, it's very straightforward. For this sales data table within the same database, this role which Emily belongs to is only allowed to see the data belonging to the US. So we can apply any arbitrary SQL predicates that are valid to restrict the access and filter those rows that Emily gets to see. You can also write coarser grained permissions at the file level. So we also authorize the underlying object stores down to the object level, whether it's S3 or ADLS or GCS. Similarly, read and write operations can be scoped down. In terms of data protection, we also offer dynamic and static masking as well as static encryption. So what you see here is there are a couple of policies that have been provided to mask sensitive information such as social security numbers and email. In the case of social security numbers, these have been hashed. And in the case of email, they have been redacted. And the policies that do this are within this environment under the masking area. So masking policies are also very straightforward to construct. We choose the column and apply the role or the group or user and apply the type of mask that you want. Out of the box, we provide various types of dynamic masking options, and these can be customized based on the usage. In addition to the resource-based policies, which are based on the location or the physical attributes of a particular entity, such as a table or a column or a file or a folder or an object, we can also have tag-based policies which represent the classification or the business context or other metadata properties of an object to drive the authorization decision. So such policies are called tag-based policies. As we saw in the discovery module, the output is a tag or a classification, and these can be leveraged extensively to write policies across all of the services that we authorize within the Privacera extensions to Ranger in the cloud. As an example, you can write a policy that restricts access to a particular role or a user or a group or some combination in a particular set of services to all of the objects that are tagged in a certain way. So in this case, anything that's tagged with sales is only available to this user, Emily, and only within Redshift and Snowflake for certain conditions. So we can, through these means, have very economical policies that apply across a variety of services and across a wide swath of your data landscape by simply applying the tags and mapping the resources to the tags that they have, either via discovery or through import from other cataloging tools. Privacera also provides encryption capabilities. So there is a capability to encrypt the data using a variety of NIST standard techniques, including format preserving encryption, AES, and other schemes. For Databricks, we provide extended capabilities beyond what the Databricks platform provides as a solution working together with Databricks to authorize at a very, very fine-grained level columns, at row level security, tables, tables and databases, as well as for other usage contexts via Scala or Java. So a variety of languages with which you can interact in Databricks can all be provided consistent policies and consistent authorization and auditing uniformly across the entire space.
As we observed in the demo, we support the entire data access governance lifecycle through 4 steps. The first step is the discovery, where we connect to different cloud storage databases, scan the data, and store these annotations within our metadata store. The second step, we can author fine-grained policies and enforce them through distributed agents that are cloud native and run and give you this functionality for role-based, attribute-based, tag-based, as well as fine-grained access control. We also saw how you can enforce policies across a variety of services and have a variety of reports and dashboards that provide visibility and give the ability for customers to be able to leverage this data from a central pane of glass. In summary, the business value of our platform is the ability to identify sensitive data across the cloud footprint, enable secure data sharing, and do this in an automated fashion without requiring a lot of human investment, and helping customers migrate to cloud and work seamlessly in a public cloud mode while being in compliance with regulations such as GDPR and CCPA, and providing a streamlined processes with integrated workflows to support all of this from a central pane of glass. That is pretty much a quick overview. Thank you for your attention. Please do visit our booth for a personalized demo and connect with us on Twitter, LinkedIn, and do visit our website for additional resources and collateral that will be useful to understand how we can help protect your data in the cloud and work seamlessly with Databricks to be able to affect these controls. Thank you.